All right, so what we're going to do today is we're going to actually start a new unit called Tonic Sections. All right, so if you look here, you didn't read this, or maybe you did, not really anything to read, but these are the 4 conic sections that we are going to / have looked at. We've already done a lot of work with parabolas. Do you guys remember the unit we did where we did parabolas? Yeah. What type of functions? It is a square. What is that called? Quadratic. So we did a whole unit on quadratic functions. So we've already kind of exhausted everything we're going to do with parabolas. So you're good there. We're going to do today circles, then we'll go into ellipses, and then hyperbolas. All right, so all of those right there we will have covered or are going to cover. All right, so today we're going to start with circles. All right, so you should have read this. And the main takeaway from this slide is you want to memorize this formula. This is the formula for the equation of a circle. All right, so we always have an H and a K, which represents the center of a circle. Bless you. And then we also have R. And what does R represent? The radius. Now, when they give you this number, it will always be the radius squared. So the trap that a lot of students fall into is they pull this number from the equation and say, that's the radius. But is that the radius? No, that's the square of the radius, so you need to take the square root to get the radius. All right, so we're working with that. All right, so let's do an example together. So it says, write the equation of a circle with a center at 2, 1 and a radius of 5. Well, what is the equation for a circle? I love it. Very good. All right, so the center is always going to be the ordered pair H, K. So just for purposes, I'll write H, K here above 2, 1. So how am I going to write that in the x minus h and the y minus k? All right, and what can be confusing that you see up here? What do you think can be confusing to students? We have 2 variables, which is definitely something that might be new. The subtraction. Guys, up here it says the center is positive 2 and positive 1. But what do you notice about these symbols here? It's subtraction. So that's where a lot of students get confused. Remember, you need to think opposite. All right, so whenever it says subtraction in here, they're both going to be positive. If this said addition, then it would be the opposite of that, so it would be negative. All right, so just keep that in mind. A lot of students forget that. Now, is it going to be equal to 5? No. What's going to be equal to? 5 squared, which is 25. So that is the equation for this circle. Any questions? That's it. That's it. It said to write the equation of a circle. Boom, there's the equation for that circle.
So use that to graph a circle.
You could leave it as 5 squared, but go ahead and just get in the habit of squaring it. Great. Well, you know how this class works? Exactly. Yes.
So use that to graph a circle.
We will graph them later today. Yes, we will use this to graph later today. All right. All right. So as Gerardo has already noticed, that was simple or hopefully straightforward. Now let's go ahead and make it a little more challenging. Now it gives us the center, but does it give us the radius? No. So I can go ahead and write the beginning of my equation. Remember, it's x minus h squared plus y minus k squared equals r squared. All right, so I can do the first part. What's the first part going to be?
X minus 2 squared.
Say it again.
Which one do we use, the 2 and 4 or the 8 and 12?
The 2 and 4 is the center. Always the center. Always the center. So I'm going to write x minus 2 squared plus y minus 4 squared equals r squared. So I do not know. Now there's actually a couple of ways to do this. Does anybody think, can anyone think of a way that we could find the radius? Well, I love it. Very good. If I were to draw this circle, what is my center? 2, 4, right? And what's the point they've given me that's on this circle? 8, 12. So I'm just going to imagine it's somewhere over here. And you said distance formula, so the distance from 2, 4 to 8, 12 would be called? The radius, right? The distance from the center to any point on the circle is going to be the radius. So I could absolutely use the distance formula. All right, and it's great for you guys because you are taking geometry, so you have that memorized. No, we don't. Who's got it? Who's got the distance formula? Okay, hold on, because we're starting to, let's say it with some enthusiasm. X2? We're going to see x sub 2 today? I think we want x sub 2. Yeah, that one. Here we go, some positivity. Yeah, that was it. Yeah, we got it. Excellent. Great job. Thank you. Now, really, when you do this, I tell students all the time, it actually doesn't matter the order here. Why doesn't it matter the order?
Because you're still going to use the same number. You're still going to square it.
You're going to square it. And whenever you square it, it's going to make it positive. So it really doesn't matter. If you did the first minus the second, that's fine too. The only thing that would be wrong is if you did x minus y. That would be wrong. All right, can't do that. So you have to find the change in your x and the change in your y. Is that the only way to do this?
No.
We'll find the slope. Now, will that help us?
Can't you plug in 8 and 12 into that?
That's exactly what you could do. Notice we have x, y, and r. And what do I want to find? I want to find r. Well, they've given us another point, which is x and y, right? 8 and 12 is an x and y. So I could plug in 8 minus 2 squared plus 12 minus 4 squared equals, and you guys have learned in algebra that if you have any equation and one unknown, you can do what? You can solve. That is algebra in a nutshell, right? If you're trapped in a nutshell, that is algebra. Okay? Any equation, one unknown, you can solve it. So you can absolutely solve that. Let's go ahead and finish what Joel wanted to, which was the distance formula. So that's going to be, and again, I don't care. We could use the center for the first one or the center for the second one. I don't care. What do you want to do? Center for the first one. So we would do 8 minus 2 squared. Right? You want to see that? 8 minus 2. Yes. Plus 12 minus 4 squared. And you guys should see it is exactly the same as this. Because we're ultimately going to do what here to find r? Take the square root. We just have already done it here. It's the same thing. So do I care which way you do this? No. A lot of students, because they just get so tired of the distance formula, will just go ahead and just plug in. All right? So go ahead and do some algebra for 30 seconds and see if you can find the distance or the radius. Same thing here. Sorry. Mariana, we found it? Great. Excellent. Thanks, Miguel. Appreciate you. What's the radius? 10. All right? Either way, doesn't matter. The radius is 10. So if I want to write the equation for this circle, I go back up here. Remember, I've already written it, but I want it equal to r squared. Now I know what the radius is. It is 10, so I erase that and write. This is where our students say 10, but no, we don't write 10. We write 10 squared, which is 100. Any questions about this? You will have to do this shortly on your own. Yes, Leslie.
So when you put the radius here, is that?
Yes, because see how I've already put the center here? The only thing I needed was the radius squared to finish it. So personally, I just go and I erase it and write the answer. But if you want to just write it down here again, that's fine too. Doesn't matter. All right. The other way? Yeah, you could have done it the other way. Talking about with the distance formula? Oh, either way, it doesn't matter. This should have given you 36. This should have given you 64. When you add 36 and 64, you get 100. So that means the radius squared is 100, but the radius would be the square root of that, or 10. Either way, you should have gotten 10 for your radius. Great. Awesome. All right, so here's what you guys are going to do. You're going to try these 4. I'm going to give you about 10 minutes to do these 4, and then we're going to start graphing them. Excellent. Great. Go!